Good morning and good afternoon, everyone. I am Cynthia Perez, Director of Education at UTC. On behalf of UTC, we welcome and thank you for attending this webinar, Securing the Digital Grid from Wide Area Communications to Substations Defense. Next slide. This webinar is sponsored by Belden. Next slide. Please note that attendees will be muted for the entirety of this webinar. However, you will certainly have an opportunity and are encouraged to ask questions. We ask that you submit your questions through the Q&A function and not the chat function. The chat function will not be monitored for questions. Please note that the Q&A function is intended for webinar-related questions and content only. Please note that after the webinar, you will receive an email from UTC that will contain a link to the webinar evaluation form. This is very important. You must complete the evaluation form to receive a certificate of attendance. You will earn 1 professional development hour for this webinar. The slides and recording will be available in networks within a week. Next slide. And finally, today's presenter, Guilherme Lisboa, Arnau Vasquez, Jon Ramirez de Olano, and Sarah McLaughlin will present the webinar. Type your questions as you think of them, and we will answer as many as we can. Remember, use the Q&A function to submit your questions. And now, I'm happy to introduce Guilherme Lisboa. Guilherme, it's all yours.
Thank you. Welcome, everyone. As being already stated, my name is Guilherme Lisboa. I'm Digital Automation Consultant for Belden. I'm going to have my colleagues here, Arnau Vasquez and Jon Ramirez, that you saw, and a surprise guest, Sarah McLaughlin. Both of them are going to introduce some parts of this presentation. I'm really excited about everything we've put together. So let's start with that. First, we're going to have Sarah talking a little about Belden. Arnau and Jon will come later about cybersecurity and everything you came for that. Keep here because it's good content. Go, Sarah.
Thanks, Guilherme. And thank you, UTC, for hosting and partnering with Belden. I'm Sarah McLaughlin, the America's Vertical Leader for Energy. Before we dive into today's technical content, I want to give you a little bit of information about who Belden is and why we're here today. Belden has been supporting mission-critical networks for more than 120 years. Our purpose is simple: to help you build networks that are predictable, resilient, and secure. Next slide, please. Belden is no longer just wire and cable. We combine best-in-class products and services across the network and data infrastructure to address your organization's specific needs. When working with us, you gain access to our industry experts and the Belden brands that you already may be using, such as Hirschman and Extran. Next slide.
Sarah?
Yeah.
As a host, I'm kind of a spy here, asking questions in the name of the audience before they can ask that. If we come back to the previous slide, one thing that I'd like to hear your thoughts on that, because Belden in the energy space in the West is very known for cables, for all of our connectivity. And here, of course, we're bringing a lot more than that. How do you see this transition, how this change and this perception from our customers?
Yes, so Belden has been supporting mission critical infrastructure for 120 years, like I said. And now that we are connecting the networking aspect of it, we're able to bring in different resiliency and cybersecurity to make sure that we are looking at the entire continuum of the network.
Thank you for that.
All right, go to the next slide, and we'll dive into who Belden is at a high level in energy. So through network convergence and connectivity, we're able to provide the ability to carry a lot of different types of information on a single platform. That means fewer networks to manage, less complexity, and lower operating costs. Network resilience is the network's ability to see issues, tolerate faults, and keep running. And this is where resilience and cybersecurity really come together. This is what we're going to be talking about today: protecting critical operations when things don't go as planned. And third is network slicing, which allows us to guarantee bandwidth for different services. We create protected lanes for mission-critical applications, so priority traffic always comes first with predictable performance. Next slide. Today, we'll focus on how improved network resilience directly ties to cybersecurity. So you will hear from some of our experts who work closely with customers to build tailor-made solutions based on where they are in their digital modernization journey. And with that, I'll hand it over to one of our experts to take you deeper into today's topic.
So that's me. Hi, everyone. My name is Arnau Vasquez, solution consultant with Belden. And on this presentation, I'm going to walking you through cybersecurity concepts for wide area communications. So, but before we dive into cybersecurity concepts, let's start understanding what are the requirements that are coming from all the applications that we're transporting across these networks. Because at the end of the day, when we design our infrastructures is based on application requirements. A network by itself is just a network. At the end of the day, what we need to put together a set is something that it's gonna be, yes, providing uncompromised reliability and security to all those critical applications. But to understand a little bit better the picture of what I'm talking about, of course, it's good to have like a kind of list of what are those common applications we're supporting with our infrastructure designs. So one of the most typical and common ones that you would all agree that is the most critical, let's say, application we usually work with are teleprotections that of course can be implemented on different flavors. For example, we can do C3794 teleprotections, serial-based teleprotections that are let's say, commonly known as mirror bits, right? As a specific, let's say, implementation or a specific, let's say, technology that's provided by a specific vendor. We can also have them on other colors, such as T1 when they are coming from channel banks for wires. And why not maybe in the future consider them as goose messages that are going to be going across our WAN infrastructures. But so far, that's not a reality. I've been part of labs where we have been doing teleprotection schemes with good messages, but let's leave it that for a different webinar. So other applications that we could also consider are SCADA, superphasers, and auxiliary systems or secondary systems such as VoIP, telephone systems, FXS, the regular classical analog telephones, and why not CCTV systems, right? So bottom line is like, no matter what's the applications, each one will have a specific requirements, and those requirements need to be made by the infrastructure that we're gonna be designing. So when we go back to the cybersecurity concept, of course, the main focus of cybersecurity is to ensure that operational continuity, right? So another thing that happens when we think about cybersecurity is that we normally connect it with intentional attacks. But I think that the scope of the conversation should be a little bit wider, should be a little bit more comprehensive, more holistic. So when we're designing these infrastructures with the focus of having or meeting all those application requirements, we need to not just focus on security aspects, but also think about predictable networks, resilient networks, of course, the other portion that are a set of controls that will allow our network to be secure, right? So as said, it's a more holistic view. Just let's say think about cybersecurity concepts or security concepts, right? Or security controls, we can put it that way. So if we start diving to every single of these concepts, right, to have this like comprehensive design perspective, we can start with a predictable utility transfer network. And when we're talking about predictability, we can actually connect it to determinism, right? Some applications that we're transporting are deterministic, for example, teleprotections. And one of the, let's say, elements that can describe determinism in what we're doing, that is transporting applications, is delay, right? Especially for applications such as teleprotection. Again, I'm gonna be, let's say, bringing the teleprotection portion all the time because it's one of the most critical applications and the one that we need to ensure that works, let's say, properly according to what the application requires, right? So that being said, one of the things that we need to have in mind when we are designing these resilience and predictable infrastructures is having low delay for such applications. So how do we calculate delay? Let's start with something as simple as that. So if we break down the delay that we can have between two ends, we can break it down on two different portions. The first one is the packetization and depacketization process that, depending on what's the source that we're having, let's say Ethernet or TDM based, or maybe analog for four-wire applications, we will have a different situation. When we're just encapsulating Ethernet frames, that's a kind of, let's say, seamless situation from an MPLS encapsulation standpoint, because we're just putting an overheading over the, let's say, the native Ethernet frame. But when we're talking about TDM frames, we're doing like an re-encapsulation of the whole, of the original, let's say, data, right? At the end of the day, it's going to be putting those TDM frames within an Ethernet frame. That process takes time. Of course, we have some controls internally to minimize that time as much as possible, as, for example, modifying jitter buffers, modifying TDM frames per Ethernet packet, and that's under our control. But when we jump into the transmission delay portion, we're going to be kind of hardware tied, hardware connected. And what do I mean with that? The transmission delay is going to be, let's say, composed by, I would say, two big portions. The first one is the transmission of the data through the media, right? That can be kind of modulated with 2/3 of the speed of light per kilometer. That's equals 5 microseconds, right? And at the same time, the switching process or the delaying switching process, if we're focusing 100% on MPLS TP as is part of the portfolio that we normally work with. In that case, if we're talking about 10 gig, let's say one interfaces, we should be considering around 5 microseconds. So compared to the packetization and the packetization process, where we're at the scale of milliseconds, of course, this delay is significant. But let's bring this concept back to the more cybersecurity kind of stuff, right? So let's imagine, for example, if we're in the situation that someone is injecting traffic into our network, let's say malicious traffic. No matter if it's malicious or not, if we're going to utilize the available bandwidth for, let's say, malicious purposes, right? Of course, we want to be covered for those specific scenarios. And one of the main focuses that we need to put, let's say, head on is the fact that that delay needs to be, let's say, kept. We need to respect the delay. So what are the tools that we currently have for making that happen? So a good design of a network infrastructure that, again, is a holistic view of a cybersecurity strategy also consider traffic engineering tools. Right here, you see a change of different, let's say, controls that we can implement from a traffic engineering perspective. And if we bring those controls into a feature-based perspective, we can actually translate it into, of course, policers, but also quality of service implementations, right? And of course, as much as comprehensive that quality of service, let's say, strategy looks like, more granularity we will have to segregate all those, let's say, applications. Second thing that is important to have in mind, especially for differential protection application, that again is at the top of the list of our priorities, is low differential delay, right? And for that specific implementation under the RFC 5654, we have co-routed bidirectional paths. That means same path, back and forth, data will flow utilizing exactly the same path, and that translates into a low asymmetry or low differential delay. So again, these are concepts that we need to have in mind to have a predictable infrastructure that is part of our holistic strategy. If we jump into the resilient portion of high availability, right, resiliency, we can actually, or in this slide, I'm breaking up what I'm trying to cover here on two different portions. The first one is reconfiguration time under 50 milliseconds, and the second one is a bumpless, heatless scheme. When to pick which? Again, application requirements, right? So let me describe both, and then on a maybe separate conversation, it's possible to define when it's necessary to implement one or the other one. Reconfigurations under 50 milliseconds can be covered depending on what's the LSP, again, in an MPLS world, because this is what I work in a regular basis, right? On a tunnel base or LSP base, we are talking about two different implementation, specifically with our, let's say, MPLS implementation. The first one is the one that it's proper from MPLS-TP, that is one-to-one linear protection defined under the G8131 standard, okay? This particular protection is as simple as main path, packet path. If the first one fails, we switch over to the second one, to the protected one, right? And that happens under 50 milliseconds recovery time. Is it always valid? That's a question that we need to do. Is it part of what we're expecting from the resiliency or from the network from a resiliency standpoint? That's something that we need to put under the discussion, right? In the case that, for example, we want to change or let's say approach the implementation for a different kind of services, such as, for example, SCADA, we will need to consider a different topology or logical topology. For example, rings. In that case, of course, the linear protection is not going to be useful because we're talking about, in the case of linear protection, about point-to-point tunnels. But in the case of rings, of course, we need to utilize a different standard. So that, again, will offer recovery times that we need to analyze if they are going to be suitable or not for the application, correct? And then regarding headless switching, that it's about 0 milliseconds recovery time for extremely critical applications. Again, we can consider this case if the application needs it. The important thing is that those technologies are available and yep, ready to go. So something interesting that as well we can talk about is how can we combine those two technologies, getting, let's say, a scheme that can tolerate up to 3 failures. That's something interesting as well to have in mind. And everything is, again, depending on what the whole definition of the application, it's going to be completely related about what's the final requirement that the application is giving to us, so we can define the network design properly. In terms of resiliency, we can also mention the concept of segregating the different planes that are going to be part of the infrastructure, right? Network management system and that is the control plane, correct? And then we have the data plane as a completely separate one. If for some reason our control plane is compromised, let's say our server is down, this segregation allows us to keep the network infrastructure up and running while we cover, let's say, the specific needs, or we recover the main server that is going to be managing and controlling the infrastructure, okay? So the third point that I was covering at the beginning of this presentation is the security controls that we can implement in a network infrastructure. From Belden, we see these strategies divided on 3 different parts. The first one is the management plane, right? That it's, let's say, the communication that is going to be between those remote clients and the NMS. We need to provide certain controls to protect that level. The second one is going to be the data plane, that is communication between the NMS and the nodes. Of course, there's going to be a communication that goes that way that needs to be secured as well. And finally, the data that it's going across, the teleprotection service, the SCADA service that also needs to be protected. And for each specific plane, right here, I'm defining several controls that might be interesting to consider as well. Right here, I'm just kind of, let's say, offering a reference from an external standpoint, but of course, every single vendor will have a set of features that, of course, can be utilized. So yes, Belden's external solution is built for power utilities, and all external systems are installed that are installed in the US are in NERC regulated environments, correct? Let's move to the next one.
Arnau, can I jump in one more time?
Sure, of course, anytime.
So the concept you're showing here, is this applicable to any platform?
Yes, of course. So of course, the set of features, the set of controls that can be utilized under a NERC, let's say, environment will depend exclusively on every single vendor, right? But for example, what I'm going to be doing here is showing how, for example, an extra infrastructure based on that feature set can be applied, again, under NERC, let's say, recommendations. But of course, if you, for some reason, you are utilizing a different, let's say, system or a different technology, of course, you will need to, let's say, recover those features that can also be implemented on a similar way, right? So let's put it this way: we're describing general good practices and not focusing on specific features to make this happen. Thank you for asking, Guilherme. Okay, so here's something relevant is of course the NERC sections are pretty wide, right? And if we go one by one, we could be the whole day talking about how can we support NERC with those feature sets. We prepared a guide, of course, focusing on our product that is gonna be released anytime soon, and it's gonna be available for everyone. And what I'm gonna be showing you on the next slide, it's like a kind of a super summarized version of what we did in that guide. And as said, we're not gonna be covering all the sections of the standard, but just a portion of them, the one that might be maybe more graphical to analyze in a conversation like this one. So let's first of all start with asset identification and classification. What does this section is looking for? So what it does is try to identify and categorize assets based on their impact on the reliable operations of the bulk electric system, the BES, right? So even though Extron is not going to be providing information about those end devices, we are going to be offering all the info that is connected to the communications that are connected to those elements, right? So again, I'm talking about Extron, but this can be explored on any system. I'm using this as a reference. So TXCare, that is Extron NMS, can provide reports of hardware, firmware, port status, fiber, let's say, a status, services, let's say, statistics, and all that information, of course, can be complemented to the information that is collected from another system that is completely tied to those end devices that are classified as critical assets, correct? So again, we're gonna be supporting the requirements that are described within this section of the standard. If we jump into the next section, that it's CIP5, in this case, if we want to summarize, let's say, what this section describes, we could frame it on 3 different words: segregation, control security, and audit, right? So let's start with the concept of segregating. Something that we need to be mindful of is that when we're utilizing, let's say, telecom infrastructures that are, let's say, that provide traffic engineering tools, correct? And of course, based on technologies as MPLS, all the traffic that it's gonna come from the one will already have a segregation based on, at least on MPLS-TP, it's gonna be based on what we define as pseudo wires, okay? In Extron, we call them services, but it's equivalent to say pseudo wires and services. So the information that is gonna come from the one is gonna be already segregated. So based on that segregation, or that has been already defined at the transport level, you can easily start implementing all the controls that later on Jon will describe at the edge level, at the perimeter level of the site. in our case, the substation, correct? Another thing that it's important is confidentiality and integrity at the perimeter level. If the information that is coming towards our perimeter, it's encrypted, of course, we're going to be hitting those two elements, confidentiality and integrity, right? Integrity is something that is going to be also done always at the lowest levels of the Ethernet, let's say, technology, right? With cyclic redundancy checks and so that's something that comes, let's say, along with the fact of utilizing packet-based technologies, right? So, but again, regarding packet filtering and ACLs, that is the next bullet that I have in my presentation. So personally speaking, and this is a personal opinion, I'm not a big fan of implementing, let's say, filtering controls at the transport network. For me, the transport network needs to be mainly focused on being resilient and deterministic. So I would definitely provide that load to external elements as the ones that Jon is going to be talking about later, correct? And yes, jumping to my next point is that, again, considering an NMS in an infrastructure, this is extremely interesting because all communications that are going to be hitting the edge where the telecom node is sitting on are going to be funneled through the NMS. That means that no communications are going to be going directly from the outer world to our telecom infrastructure. And the second thing is that if we're going through the NMS, all the information is going to be encrypted, right? In our case, particularly, we're using SNMP version 3. That, of course, requires credentials, and those credentials are for authentication, also for encryption. And of course, those facts provide, let's say, a more secure data or a more secure management traffic that it's hitting the edge of our infrastructure or our electronic perimeter, okay? Yes, so that being said, of course, we could, let's say, spend some more time talking about how we can enhance the protection of our electronic perimeter. But yes, I think that with those points, you're already getting the idea of what we're trying to achieve with this conversation. So if we move forward, yes, change and vulnerability, that is management, that is defined in SIP 10. Right here, from a telecom perspective, we can provide some interesting insights. We got to think that when we're using NMSs, what we have is a centralized point of configuration and supervision. So all the configurations, at least in, for example, to give an example in our system, are going to be sitting on the NMS, okay? So if for some reason any configuration in the infrastructure is changed, as we will have the source of truth at the NMS level, we're going to be able to detect those changes. So from a change management perspective, we have an extra control of what potentially is happening on the field that could differ from what we have at the NMS level, correct? Of course, every single change, every single logging that is going on in the NMS, it's going to be recorded, okay? And that's going to be stored in an audit trail. So real change management is going to be always tracked because of the benefits of using an NMS infrastructure or NMS system, correct? And something that is really interesting, right, that is also connected to change management. If for some reason we need to roll back to a safety place in our system, the fact of utilizing an NMS and having, let's say, our source of truth sitting at that level, that of course needs to be protected with certain, let's say, implementations that we're going to be, let's say, considering to enhance our security controls in our control center, okay? As said, that source of truth will allow us to roll back in case that we find ourselves in a situation where the infrastructure needs to be recovered, okay? And last but not least, I'm gonna try to keep this short and sweet. This is the last, let's say, it's the last section that was added in NERC not so long ago, that is already adding, let's say, the possibility on detecting malicious activity, right, on our sites. And of course, the network infrastructure is gonna be, yes, definitely critical for that specific purpose. Why is that? Because at the end of the day, all the traffic is gonna be going across it. So if our, let's say, feature set, we have poor mirroring functionality available to span the traffic across or through or towards those sensors that are gonna be analyzing vulnerabilities of our systems, of course, is something that we always need to consider while we are defining the controls that we're going to be implementing in our network. All right. And that being said, I will pass it over to you, Jon. And yes, all yours.
Thank you, Arnau. Very, very nice and detailed presentation on Ixtran. That is in my heart, you know, my experience with Ixtran. So please let me dedicate the next minutes to describe the association between NERC and 62443, and then come to the fun part, which is the technical blueprints where we think we can fit in NERC compliance thanks to the technology of Belden. Next, Arnau. Okay, so comparing both standards, and please allow me some oversimplification here with the target of being very clear and make sure that the message is retained. I will simplify some concepts to make it more clear, and I will do some assumptions in my explanation. Please forgive me, those experts in 62443, please. So from one side, we have NERC, which is a standard, it's a regulatory standard, so it's a mandatory standard. But I will say the focus when analyzing the NERC is on organizational control. So it's explaining the policies that you need to implement and the procedures. It's very detailed in certain procedures, like how to create a new user, how to delete it from the system, how to give authentication or authorization, but not so much on the technical details. So NERC is explaining those controls and also is requiring evidence, documentation, and audit. Then we have the perfect complement to NERC, which is 62443. Is a framework, is a standard, is an optional standard, but will help us in this compliance with NERC. It's based on a risk analysis, and the specific thing and the most pragmatic thing of 62443 is that it's allowing us to provide this segmentation of different zones and associate the proper security levels of that zones, leading to a final selection of technical controls that will help us in achieving the security of our system. We can summarize 62443 as a standard that will help us in the design, implementation, and improvement of our OT security. Here we did an exercise trying to combine the different sections of NERC with the different sections of 62443. Don't take it as written on stone. It is subject to interpretation, but mainly what we see is the connection of every single section of SIP with the first section of 62443, because it's where we define a security program. How to comply with NERC? Well, basically taking the detailed organizational procedures into our security program, as simple as that. Plus, we can find different system or even component requirements in 62443 that will help us complying with the controls defined in NERC. One very, very important point in 62443 is the concept of maturity level of our security program. Since NERC is requesting evidence, documentation, and audit, we must make sure that our security program reaches a certain maturity level to provide such evidence and documentation. Let's see a pragmatic application of 6443 for a SCADA system. First, as in any risk analysis procedure, we need to define a target of our cybersecurity. Let's say our target is we want to protect a SCADA system. Then we need to identify all the elements that participate in this system. Not only the asset, not only the server and the PLCs, but also the users that participate in this service, the building, the physical measures, and even, and very important for us as Belden, the underlying network. And third, once we have identified everything that participates in the process, is where we can drive this risk analysis, evaluate the risk, evaluate the consequences of the risk, and then select the proper controls. And here is an important added value of the standard, that it defines different security levels for our zones. Obviously, we will not have the same security requirements for a SCADA system than for a CCTV system or for an IT-related system. The standard defines different security levels depending on the skill of the attackers. But normally in mission-critical networks and in energy, it is most likely that we will select security level 3 for a SCADA system, if not 4 when we talk about, let's say, nuclear facilities. And last, very pragmatic, we have a checklist. Once we have selected a target level for our SCADA system, we will run through a checklist to see if we meet the target. I'll give you an example. If I take the first requirement, which is human identification and authorization, I will run through the checklist. First, do I have human user identification and authorization? Yes. So I can meet security level 1 for that requirement. Is it unique, or do I have an identification for a whole group of administrators? Let's say it's unique. One for Arnau, one for Jon, one for Guilherme, one for Sarah. Perfect. I meet security level 2. Is that multi-factor authentication? No, it is not. Well, the standard is helping us identifying what is missing to achieve this security level, and then select the proper controls to mitigate that. And as easy as saying, I need a multi-factor authentication. Easy.
Oh, can I make a question?
Sure.
So as we know, pretty much the whole audience here is focused on energy, power grids, and etc. on that domain. 6243 is more of a generic specification, right? How can we translate this? How can we make a link, or how can we really land this ship called 62443 in the energy space? Is there any recommendation and any insights on that?
Yeah, very good point, Guilherme. I didn't explain that part. Yes, 62443 is generic for industrial automation and control systems. But already inside the standard, you see references to the SCADA model. So they have reference models which are generic for any industrial automation and control system, and they go more in detail in the energy industry with the SCADA reference models. And inside the standard, now they are expanding the standard to specific profiles, and the first of which is the energy profile. So we will see appearing, I think it's mid-2026, a new profile based in energy, where we will find a more specific reference models.
Thank
Good
you.
point, yeah. Okay, so wrapping up, if we want to meet NERC through 62443, we need to aim, I'm oversimplifying, but that's the, I guess, 95% of the cases, the risk analysis will conduct to this. We need to meet a system with a security level 3, which means we want to protect it against skilled adversaries with decent resources. And we will provide strong authentication, monitoring and response, of course, and of course, secure segmentation and architecture. That we'll see in a moment some examples. And what about the maturity of our security program? Well, since NERC is asking to provide evidence, audit, and proper documentation and control, we need to aim at a security program with maturity level 3, which means it's a managed security program with clear responsibilities, with evidence, with version control for all the changes performed, and very important, with effectiveness metrics. So we will have metrics on our security program in order to rework on it and improve with time. Okay. Now, I think the target is clear. We're aiming at 62443 SL3 system. So as Belden, what can we provide? How can we help? Well, we propose an integrated solution, which is modular, with different modules that can be used to reach this SL3 system compliance. The first of the modules is based on NAC. So we will have network access control based on identity, and which can define different policies, whether enforcing a port shutdown, changing a VLAN, or just sending an alarm, depending on the user demand and on the criticality of the system. Second, we can provide a next-gen firewall with the OT enforcer from Tofino, which is very known in the industry. So we combine the features of a next-gen firewall with our OT enforcer available in Tofino. All that in an OT substation grade firewall. A very common question is how to provide a secure remote access with multi-factor authentication. Well, we provide a tool for that and a proper architecture to avoid connecting our process bus directly to the internet, as we can see it's happening in the market. The fourth point is about visibility. We are all familiar with the security in-depth concept, but we must be familiar with the monitoring in-depth concept. We want to monitor the flows, not only when they cross the firewall, but also when they are happening inside our zones. So for that, we need the monitoring in depth through IDS and anomaly detection. And last, this is a very important piece of the puzzle, is an OT orchestrator, which is Belden Horizon, to orchestrate our network and security. Most of the vulnerabilities is not exploits and hackers ultra sophisticated. Well, it happens also, but many vulnerabilities are associated to configuration. It's crazy. You see the statistics. You can buy the best firewall in the world, that if you don't configure properly your firewall or you don't configure properly your switches, you will have plenty of vulnerabilities. I cannot draw a figure, but very high percentage of incidents happen because of wrong configuration. Okay, let's go to the fun part, is associating drawings to and blueprints to SIP. What about SIP 02 asset identification and classification that are now very well explained in his part? How can we help identifying the assets connecting to your network? Of course, you are in the best position to understand your process and the different assets and create an inventory. But we can help you and assist you with our NAC in a very simple manner and without any impact in availability of your service. Our NAC will connect to the different switches of the network through simple SNMP version 3 for more security, and we'll learn the different MAC addresses of the switches of your network and create a list of the MAC addresses or the endpoints connected to your whole network, whether you talk about the substation, or the station bus, the process bus, your management network, wherever. And then you can manually classify those into groups for further enforcement. Next, SIP 07, System Security Management. This is a very important part. We need to make sure that we control the configuration of our port and services. We don't leave ports open, giving direct access to certain VLANs. We need to manage our security patches, prevent malicious code, and also make sure that we give the least privilege, not only from the role in an airbag authentication, but also from the network perspective. We give the least privilege, we give you access to only that VLAN. Let's see how we can do it. Reusing our NAC controller, not only in visibility, but in enforcement, we can associate each endpoint group to a VLAN. We could even automate, that's decision to be taken by the end customer. If we do it automatically or just in assistant and monitoring aspect, we can associate an endpoint to a VLAN and send an alarm if we see an endpoint connected to a wrong VLAN. If we go for the enforcement option, each element of each group will be associated a VLAN like we see in the example. 99, 100, the goose will be associated to 200, etc., etc. So you make sure that when an endpoint of goose is connected to any port of your process bus, it will always receive the VLAN 200. And if it's removed, we are unlucky, someone has physical access, wants to remove our IAD and connect its own device to perform an attack, it will be rejected and the VLAN 200 will disappear from that port. We will also enforce other VLANs like use VLAN 900. So if you disconnect a port, it will get an isolated VLAN like 900. If you connect a non-authorized device, you will get 901, as you see at the bottom in red. A new device will get either a port shutdown or an isolated VLAN. And what happens if I connect a device that is in theory authenticated, but we receive an alarm from the antivirus or from Windows Update? Well, we can take the decision of putting it in a quarantine VLAN temporarily until the problems are solved. And as you can see, our switches are now authenticating our IADs, our merging units. You see the check in all the ports, and they are protecting the trunk ports automatically. They detect that two switches are talking to each other in the trunk port and will avoid any shutdown of those ports. Now, the funniest part for us that we are network providers is how to define an electronic security perimeter. We are experts in network design. Now we need to associate our expertise in network design with security, so to perform a secure network design. So we need to define a security perimeter using the tools we have in Belden, whether we talk about the NAC, the next-gen firewall, or the switches. So I will divide this part of the standard in 4 points. The first is this, how to define a security perimeter. For that, we have a next-gen firewall, which has the OT enforcer to monitor the OT traffic between different zones, but we also have optional IDS to analyze signatures. We have web filter tools to analyze browsing traffic, and even DNSSEC to avoid the hijacking of DNS connections, which we see an increasing attack vector. And as I said before, we have the option to automate the VLAN assignment in the switches through the NAC. Second, access control. So we can do an access control based not only in MAC address, but if the endpoint only allows that, that's the best we can do. It's easy to spoof, that's it. But we can also enable additional access control based on 8021X, based on user password, or even, and ideally, on a certificate. How can we decide if this credential or this certificate is authorized? Well, we have an embedded credential repository in our NAC, and we have an embedded PKA, or certificate management, in our firewall. Third, and this is a very recurrent question from my customers, is how can I provide a secure VPN? We see also an increasing number of attacks through the supply chain. Some integrator connects, some supplier connects through a laptop which hasn't passed the proper security checks, and then somewhere enters in our network. So for that, we have a tool to provide a secure remote access with MFA, and also combining with the health check of the laptop connected to the network. And we have this secure architecture where we deliver this VPN to a DMZ prior to access our mission critical network. In that way, we avoid direct connection from the process bus or substation bus to the internet. And we see that you can use Shodan if you have some time to have fun and detect PLCs, IADs, anything you can think of directly connected to internet. How can it be possible? I don't know exactly, but they are connected. And last, very important part is the monitoring and logging. Our switches are 62443 SL2 certified, which means they have the proper security tools and also the logs and to provide information to an CM umbrella. This is a very crucial part in security. Plus, we have the combination of our tools with a sensor to monitor any anomaly inside the network. What about the supply chain management? Is now the rising concern also in the 62443 standard. In fact, the last version of the standard is putting the accent on this. Well, us as vendor and many vendors, we have a product approach. So we go directly to the component requirements to make sure that our products are developed, implemented with a secure development life cycle. And second, that they implement the proper tools for security required by 62443-4-2. But the standard says that that providers should also are also impacted by the system or the solution approach, which is the -3 part of the standard. So even if integrators are the main audience for that part, we as vendors, and especially Belden, that we work in a solution approach, we must be familiar with that part of the standard and enable the integrators to give the best solution, the best possible solution when integrating a whole system. So we cannot be blind as vendors to only the component requirements, but we must learn from the system requirements in order to improve our products and our architectures. I found this, when doing this presentation, I found this white paper, which is very interesting, that explains how you can meet 100% of the supply chain requirements of SIP 13 through 62443-41. I recommend the lecture of this white paper, very interesting. And we come to the last blueprint, which is the internal network security monitoring. In combination with the NAC, we can add this sensor that will monitor the traffic happening at the layer 2. It's easy to control the traffic when it's crossing a firewall, but as we know, in the process bus, it's very complicated to cross all this traffic through firewalls because we have delay and we have availability considerations. For that, we can deploy different probes in the station and the process bus, as you can see here in the picture, which are mirroring the traffic of the different switches. Then in the sensor, in the brain of the substation, we can load an SCD file which describes the baseline, the flows that we expect in the process bus. So the GUS and the sample values flows, in which VLANs, which application ID. And from that moment, we will set the baseline of the traffic. After that, everything that differs or deviates from that baseline will set an alarm to the CM and potentially, to be decided, an alarm to our NAC for future enforcement. Other people call it a SOAR. Well, it's exactly the same concept. Which kind of alarms? Well, you can think of many. I'll give you some examples of alarms that we can detect. What if we see in traffic 104 or DNP3, what if we see a test APDU or a similar test communication that has not been seen before? Well, that will trigger an alarm. What if we see an unexpected communication coming from an ID, like an SSH is not supposed to have? That means that my ID has been compromised probably, or someone is not following the procedure. You're not supposed to trigger an SSH from an ID. What if I have a wrong GUS ID? I have defined a certain number of flows in GUS, and then I have a new one. Is it normal? Is someone trying something? Or it's just that I didn't define the SCD correctly, or I didn't upload the SCD file properly in my sensor? That could happen. And last, what if I have a device sending this start TDT in 104 or the equivalent in DNP3? Well, that means that someone is trying to scan the network to detect IDs. That's typical of some malware like Industroyer. Is sending commands that are supposed to be sent by the SCADA, but I see them happening from a different source. Thank you very much for your attention. I try to be as clear as possible. Not easy when we talk about standards and regulation. So please don't hesitate to ask any questions now or at any other moment. We are at your service. It's a pleasure to be here.
Thank you both. Oops. Oh, I'm not on mute. Thanks both Arnau and Jon. I thought I was on mute and I was speaking without you listening, but okay. So we actually I have a lot of questions, but I will spare you those. We can catch up later. But we have some questions that came from the audience. I'm going to share with you guys. I think each one of them are very tailored for both of your presentations, but feel free to help each other. Okay. So the first one, I think it comes back to your presentation now. Apparently, somebody really paid attention to the slides. Can you explain how hitless switching works and what role it plays in securing and stabilizing the grid?
Yeah. So connecting this concept of hitless switching to my presentation, when we're talking about redundancy mechanisms, we're talking about resilience, right? And one of the main focuses of cybersecurity, again, is operational continuity. So that's the first part. The second part is that how does hitless switching works? So hitless switching, first of all, is defined at the service level. It's a property that can be defined for a pseudo wire that at the same time is a circuit emulation service. So when you create or you enable this property within the service, when you are defining what are the tunnels that or the LSPs that are going to be transporting this service, you're going to be requested to select two different tunnels, okay? Path A and path B. Of course, path A and path B, they need to be physically independent, okay? Let's think about a ring. You know, one is going to be this one and the other one is going to be that one. So what it happens with hitless is that at the service level, we're going to be duplicating the traffic, the native traffic, using one of the paths and the other one of the paths, right? So as we're duplicating the traffic, if one of the two paths it has been compromised because of a fiber failure, because of a human error, or whatever it is, that specific failure from a service perspective, it's going to be seamless. So everything will remain working no matter we had a failure in the system. So like 1 minute explanation, I think that's more than enough. Yeah.
Yeah, we still have a few minutes before that. So at least the next one I'm going to fire. Jon, if you want to compliment Arnau after that, okay. But especially on the whole framework that you're showing, the question is, what sets Belden's cybersecurity concept apart from other offerings that exist in energy?
Okay, good point. Okay. Well, the fact comes from our general approach. As Belden, we are working not only as a vendor, also as a solution vendor, not just a product vendor. So what we are applying for the network, we are applying in the same way for the cybersecurity. So we don't remain our silo of vendor, but we need to think and we need to enable the different integrators when enabling this system security. So when I start working on this concept, on this exercise of a whole system, I had to take into consideration not only the component requirements, also the system requirements. And for that, we have to understand what is the whole process of cybersecurity. Things that not everyone explains. When you talk about cybersecurity, a lot of people like to talk about complex concepts, but nobody explains from the base, from scratch, where to start from. To do the risk identifier, risk analysis, then is the system, and this is the component. So we want to participate, or at least be an audience in every part of the system, although we are not experts in risk analysis, don't take me wrong, but understand all this process and collaborate in all this process, at least as participant in all this process and everything in every part where the end user or the integrator needs us. So I would say we have more implication in the whole solution.
Okay. Jon, Arnau, we're at the top of the hour. We could go on questions, like I said.
All right.
I think that we're gonna really deliver 1 hour as compromise to our audience. But again, I'm pretty sure that everybody here has our contacts. Feel free to reach out to us. We can continue this conversation with any one of you. If you haven't seen Arnau and Jon both take pleasure in having those calls, this is something that really excites them. And here in this audience, I was really happy. I want to see more of that. So we're gonna close now. But thank you so much for your patience, for your audience, and hope to hear from you back soon.
Just
you.
another reminder that the presentation slides and recording will be available in networks within a week. Once again, I want to thank all our presenters for their very informative presentation. And thank you all for attending. Have a great day, everyone.
Have a great day. Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye.